Hello, good morning to dear panels, lecturers, and my dear friends. Today I would like to present about our project. That is, the title is Lumen Tracker for Solar Panel using DC motor with Arduino. Okay, so before I go into the presentation, I would like to introduce myself. My name is Lingesh Sananalaki Subramaniam. Numeric 09 DEM19 F1043, and I will be the first presenter. Okay, our supervisor name is Inche Irison bin Adam. Okay, so I would like to continue our presentation with abstract. Energy crisis is the most important issue in today's world. Conventional energy resources are not only limited but also the prime culprit for environmental pollution. Renewable energy resources are getting priorities in the world to lessen the dependency on conventional resources. Solar energy is rapidly gaining the focus as an important means of expanding renewable energy uses. Solar cells, those convert sun's energy into electrical energy, are costly and inefficient. Different mechanisms are applied to increase the efficiency of the solar cell to reduce the cost. Solar tracking system is the most appropriate technology to enhance the efficiency of the solar cells by tracking the sun. A microcontroller based design methodology of an automatic solar tracker is presented in this presentation. Light dependent resistors are used as the sensors of the solar tracker. Okay, this is our abstract for the project. Okay, let's see the problem statement. Okay, the first one I will choose roof issues. Okay, why roof issues? Because when we fixed in same position at the rooftop, there will be some damage will happen to the roof, and also the lack of flexibility. When we fix it, there will be wind issues. Sometimes the current wind is very strong, sometimes rainy, windy, so there will be a problem with the flexibility. Okay, the next one is the fixed solar panels do not aim directly to the sun due to the constant motion of Earth. This will reduce the output of electricity from the solar panel. So this is also one of the problems. And the next one is the solar panel should not affect the integrity of your roof. Okay, and price. Solar panels are always high price, and also when we fix at the rooftop, it will more costly because there will be workers try to fix the solar panels, so it will be really risky job, and it will damage the rooftop. Okay, the next one is solar panels are more expensive. Yeah, just now as I explained, it really expensive because the resources are not quite big, so there will be lot expensive. Okay, next. Okay, objective. So what's the objective of our project is to innovate a device that can track lumens constantly and also move very actively, so we can collect a lot of lumen trackers, and it will be really helpful and also save more energy, and also that will be not really expensive, and there's no need to hire workers to fix the solar panel. Okay, that's all for my presentation. Thank you, and now I will be give to the next presenter, that is Davusuri Analaki Tamilarsu. Thank you.
Hello, good evening. My name is Davusuri Analaki Tamilarsu, and I'm from DEM5B, and my matrix number is 09DEM19F1073. So I am from DEM18. So the project that we have chosen is Lumen Tracker for solar panel using DC motor with Arduino. So I would like to explain about scope of our project. Okay, this device purpose is to maximize the output from the solar panel. Okay, in example, usually the solar panel will be in a flat surface, such as on roof or other place. But in this case, we want to make the solar panel to rotate. So from here, we can get more efficiency than before from a stationary. Before this, the solar panel will be in a stationary, but after that, when the solar panel can rotate, we can get more voltage and more energy than before. So the second point will be to make an automated dual axis solar panel by control X and Y axis. Okay, in this case we are using two DC motors. Each of the motors will replace X axis and Y axis. This will rotate the solar panels. So the third point will be to detect the position of light by using LDR. So in this case we are using 4 LDR. So each of the LDR will represent north, west, east and south. So by doing this, the LDR can detect where the sun is, where the sunlight is getting more, can get more light. So the solar will focus on the light. Okay, the fourth point will be to monitor the voltage of the solar panel by using a display. So we are using a display, so we can detect the voltage of the solar panel. And lastly, we are using Arduino Uno R3 and programming are used as microcontroller. So in this case, we are using Arduino Uno R3, which can control the LDR, switches, motor driver, and many. So now we can go for the second slide. Okay, so the main component for this project is, the first one will be Arduino Uno R3, which is the brain of this project. Arduino Uno is a microcontroller board based on the Atmega 328P. Okay, so in this case we are using Arduino Uno R3, which is the main components or the main brain for this project. And the second one will be, we are using L298 motor driver. L298 motor driver is a controller that uses an H bridge to easily control the direction and speed of up to 2 DC motors. Okay, so as I just now told that we are using 2 DC motors. Each of the DC motor will represent X and Y axis. So in this case we are using one DC motor which have 4 inputs and 4 outputs. So the third point will be LDR, photoresistor. So we are using a photoresistor to detect the presence of the sunlight, and it's able to rotate past the sunlight. So the fourth point will be resistor 10k ohm. This 10k resistor make excellent pull up and pull down in parameters. Same goes to the resistor 1k ohm, but in this case we are using resistor 10k ohms for the switch, while resistor 1k ohm for the LDR. Okay, and the sixth will be push button, switch, push pull. Okay, in this case we are using a push button. We are using 4 push buttons. Each of the button will represent north, west, east and south. By press those buttons, we can able to rotate the solars manually. So the 7 will be toggle switch. Okay, in this case we are using 2 toggle switch, which is can enable auto or manual mode or X or Y axis, which means we can control single axis or dual axis. Okay, the 8 will be gear DC motor. Okay, in this case we are using a gear DC motor which have 55 RPM, 12 voltage, that able to rotate around more than 500 grams of weight. And we are using a solderable breadboard. Look, in this case I am using a breadboard. We are using a breadboard which is, we solder our resistor, switches and the input and analog pins for the Arduino. And last, we are using a solar panel. The solar panel that we are using is 65 volt wattage. It can provide more than 24 voltage, and it is lightweight and it can be able to flexible. And the last one will be the main component, of battery. This battery we will use to safe to charge the battery by using solar panels, and this battery will help to rotate those motors, and we can use for external purposes such as charger, laptop charger, or mini refrigerator, and many more. So the project operation will be okay, in this case we are in this project there is two mode, which is manual mode and auto mode. So first I would like to explain about the auto mode. Okay, when it comes to the auto mode, the first thing will work is about LDR. Once the LDR detects the presence of the sunlight, it will send those signals to the Arduino by using analog pins. Once the Arduino absorbs those signals, it will send those feedback to the motor drivers, and motor driver will send to the motors. So the motor will turn to the most lumen or most sunlight or brightest place point. Okay, then so this will continuously loop once the sunlight is getting moved or the brightness has been changed. So the manual mode is we are using a 4 button, which is north, west, east and south. So once we trigger the manual mode, once we change from auto to manual mode, those 4 buttons will be triggered. So once those 4 buttons trigger, we can change as our comfortable on our comfortability. So that's all from me. Thank you.
Selamat sejahtera. My name is Anggalau. My matrix number is 09DEM18F1079. I will explain about literature reviews. Humans being faced with oil and coal depletion of fossil fuels, such a serious threat that this fossil fuel is a one-time, non-renewable resource, limited reserve, and large amount of combustion of carbon dioxide causing the earth forming deterioration of ecological environment. With the development of society, energy saving and environmental protection has become a typical issue. The green energy, also called the regeneration energy, has gained much extension nowadays. Green energy can be recycled much like solar energy, water power, wind power, biomass energy, terrestrial heats, temperature difference of sea wave, morning and evening tide, and many more. Among these, solar energy is the most powerful resource that can be used to generate power. Next is methodology. In methodology, I will explain about projects 1 and 2. First step is find the component and material, and we do the design of project. After that, we do the practical work. Practical work divided into 2 parts. First part is mechanical work. Second part is electrical work. In electrical, we do Arduino coding and wiring, and then simulation and programming. That is the test run. In mechanical part, we do process like drilling, cutting, and measurement. After that, test the project, and then we combine the 2 works and manage to create the project or projects. Then we do some troubleshooting if the trouble or mistake in our projects. Next is cost of the project. The component we buy is 10 watt, drill bit, switch box, screw and bolt, dry cell battery, workbench, push button, wire, sandpaper, LDR, Arduino Uno R3, LM259C DC LED voltmeter, and DC motor, flexible solar panel, Arduino DC motor driver. The total cost of the component is 320 cents.
Assalamualaikum and hi to all the panels. My name is Muhammad Fadli Fahmi bin Mazli and I'm from DEM18 group. My metric number is 09DEM19F1029. This is our project drawing, or specifically the engineering drawing. So this is the plan we used to sketch the project using the Inventor Autodesk software, and this is the measurement, the exact measurement that we use in our project. So basically the look is like on the right hand side view. As you can see, the solar panel is attached with a 2 pole between and can rotate with dual axis by moving using a DC motor. Next one is the circuit design. So basically this is our circuit design I used, and this is all the component that I use. Mostly just a medium cost and not very expensive component. We use Arduino Uno R3 as our microcontroller and 4 push button to move the solar panel manually, and we use the PV solar panel to activate the solar panel to move automatically. And this is the motor driver which attached with the motor that are used to rotate and drive the solar panel up and down, left and right. Next one is the result. The weight approximately is 11 kilogram. So the estimate cost, the exact cost of our project is 322 ringgit 20 cents. And the time spent for the device or our project operating is 30 seconds approximately. Next one is the reference. This is the reference that are used by our team, and you can check it by the link given. That's all. Thank you for watching.